My name is Benito Perez. I'm on 6th semester of Mechanical Engineering in CETIS Universidad. On the first part of this tutorial, we'll create our geometry. We go to File and New, and we create our new database. Our name for the file will be Anchor. Then we click OK. On tolerance, we need to have based on model. On model dimension, we put 70. Then we click OK. We need to import our model. The model will be IGES. We choose our anchor.igs as our file. And we click Apply. We'll get an import summary window with what we are importing, and we click OK. Now we have our model. We click on Shaded View and on Isometric View. And now we can see the model. We go to Geometry, Create, Surface, and Curve. An option we need to have to curve. We uncheck the auto execute, and for the starting curve list we select that line and the ending that one. Then we can click Apply. Now we go to Create again, Surface, and on Method we change it to Trimmed. We'll need to change the view of our model. We go to Home and we change the view. Now we go to Auto Chain. We select our start curve with that line, and here we have two options. We click Next and we will highlight the next line that we want for our curve. When we choose which one we want, we click OK. OK, OK, and OK. Once it's done, we click on Cancel. Now, on Outer Loop List, we select the curve we just made. And then we click Apply. We pick Yes. Now we change the view again. We go to Delete, Any, and in Geometric Entity List, we uncheck the auto execute, and we need to delete the two faces in the front of our model. We click Apply. Now we go to Create, Point, and Arc Center. We uncheck the auto execute, and on Curve List we will select that one and the one below. Then we can click Apply. As you can see, there's the center. We go to Coordinate and 3 point. We change the type to Cylindrical. And now we need to click on our points. To do that, we change the view to wireframe and we make the dots bigger. We uncheck the auto execute. For the origin point, we click that one. For the point on axis 3, we click the coordinate below. And for the point on plane 1, 3, we choose the one on the side. Now we can click apply. We change to shaded view again, and we make the points smaller again. Now we go to transform, curve, the method will be translate. In type of transformation, we pick that one. Our coordinate will be the new coordinate, coordinate 1. And for translation vector, we need to pick 2, 0, 0. We uncheck the auto execute, and we need to pick this curve. Now we can click apply. We go to edit, an object, we'll pick surface. On method break, the option will be curve. Then we uncheck the auto execute. On surface list, we'll pick this surface. And on break curve list, we'll select the curve we made before. Now we can click apply. We click yes. Now on option, we go to parametric. The break direction, we change it to constant B direction. On break curve, we need to have 0.5. We zoom on this part of the model. And we want to break the surface that is curved. We uncheck the auto execute and we pick that surface for the surface list. Now we can click apply. We click on yes, and it has to be cut horizontally. We can see the line, so it's okay. On method, we go to add vertex. For the surface, you can write it down, or you can select it on the screen. It will be this surface. And for the point, it will be this point. Now we click apply, and we need to do the same with the opposite side. We make sure everything's okay. And we click apply. Now we go to transform, surface, and we go to mirror. To define the mirror plane normal, on our toolbar, we'll need to select the 3-point. And now what we want to do is to pick 3 different points on the plane that we want to mirror. In this case, it will be these 3 points, but you can pick any. There's the 3-point. Now we uncheck the auto execute, and on surface list, we need to pick all the surfaces. Once it's selected, we can click on apply. To finish the piece, we need to mirror it one more time. So we'll do the same. We erase this, we go to 3-point and select 3 different points from this plane. And again, on surface list, we erase this and we select all the surfaces. Finally, we click apply. And now we have our full model. We click on wireframe, geometry, create, solid, B-rep, and geometric source we need to have parasolid. We uncheck the auto execute and we select our whole surface. Then we click and apply. As you can see, it says one solid created. So our solid is ready. Now we only want to keep our B-rep. So we'll go to home. We make sure we are on wireframe. We click this icon, the plot erase. For the selected entities, we click on geometric entity and we find solid. We click on our solid, it will be solid 1. We erase all and we plot. Now we have our figure. On the second part of this tutorial, we want to create a mesh for our solid. So we go to meshing, create an object, we click on mesh. The type will be solid, element shape TET, measure TET mesh, and topology TET 10. On the parameters, we need to make sure that it's on default and then we click OK. For the input list, we will have solid 1. We uncheck the automatic calculation and the value we change it to 20. Now we click apply. Now we can see our mesh. There we go. Now we go to verify, element, boundaries, and free faces. We click apply, and now we can see our free faces. We go to TET, all, and we click apply. Now we click OK. With this, we determine the element quality with all tests. Now, on the summary window, we can see the tests we made, the number of failed phases, the worst cases, and the element that made poor on our test. Now we'll click on cancel. And we'll go to test, aspect. We'll make sure on aspect ratio to be close to 5. In my case, it will be 6, around 6. And we go to apply. Now we're looking at the element aspect ratio using the fringe plot. And now we want to rotate mesh or geometric solid. So we click on mesh, solid, the same element shape, measure, and topology, and now we go to parameters. We change this one to 0.05 and the global edge length to 0.1. Now we click on OK. We click apply, OK. And then we have our new mesh. Now to compare, we go to verify again, all, and we apply and click OK. So now we'll be able to see the difference between the default test mesh and the one we just made. So now we can see our results, and as you can see, on worst case, our remesh is way better than the first mesh we made on all the tests. For example, on aspect, the one before was around 20 and this one is around 4. So now we're done. For the third part of this tutorial, we want to create loads and boundary conditions on our model using fields. So we go to wireframe, plot erase, we erase all, and on selected entities we write solid 1.1 2 points hashtag. Then we hit plot. We click OK. So we go to geometry, create, point, and arc center. Now on curve list, we need to select some edges of the holes. Select this one and this one. Then click apply. And now we need to create a cylindrical coordinate system. So we go to coordinate, 3-point, on type, we need to have cylindrical. For the origin point, we pick this one. For the next one, it will be that one. And for the point on plane 1, 3, the one on the side. And now, click apply. Now let's create a field for pressure loading. We go to Fields, Spatial. On Method, we need to have PCL function. The field name will be sin theta. For file type, scalar. And for coordinate system type, real. We'll need coordinate 2, the one we just made. And for scalar function, write this: sin r and t. Now click enter or apply. And now to create the pressure loading, let's go to loads, pressure, element uniform. The name will be pressure load. Now let's go to input data. On load VC set scale factor, we need to have 1000. We click OK. And now let's select the application region. We need to select these 4 faces. We click on Add and OK. On input data, you also have to select the sin theta. We click OK and then apply. And now we have our loads. Now we have to constrain the washers. So let's go to create, displacement, nodal. The new name will be fix add washers. We go to input data, and for translations we'll have 0, 0, 0. Then we click OK. Now let's select the application region. To select these ones, we need to change the view. Let's go to Shaded, and we need to change the view to the one from above. This one. We go back to loads, and to select application region. We need to select surfaces or faces, and now we pick these 8 faces. We click on Add, then OK, and finally Apply. Now we have constraints on the washers. We change the view again to isometric. And now let's go to plot markers. Select both the displacement and the pressure. On group filter, we need to have current viewport, and on select group, default group. And click enter or apply. With this, we finish this part of the process. Now, for the final part of the process, we need to analyze our piece. For this, we go to load cases. On action, we hit modify, and we check on default if everything's there. In this case, we have the washers and the loads, so it's okay. We go to analysis. On analysis, we have entire model. The method will be full run. On the parameters, we need to have these settings. We click OK. And in solution type, we need to make sure that it's linear static, and we click OK. We click apply. Yes. And Nastran will run the program. Now we go to subcases. We need to make sure that we have selected default. And click apply. We click yes, cancel, and on subcase select, make sure you have default. OK. Click apply and yes. Yes again. And yes again. And Nastran will run the program again. Due to limitations of my version of Patran, the analysis wasn't able to create the XDB file. So I'll explain the next step with the slides. On analysis, we go to access results, attach XDB, and results entities. Click the select results file and pick your ankle XDB. Now we go to results create deformation. Then we select the SC1 default and select displacement transformational and click apply. It should look something like this. Now to view only the deformed shape, we need to click on display attributes, this icon that you can find here. Now select wireframe, deselect show on deform, click on plot erase, click erase for geometry, click OK and apply. Now to view the bond misses stress, you need to go to results, create, fringe, select the SC1 default, select stress tensor for select fringe result. Under the quality, select bond misses and click on display attributes. Then select the element edges and click apply. It should look like this. Now let's show a fringe plot for a subset of elements. Click on target entities, the icon right here, select elements, and on select elements we select the ones illustrated here. Finally we click apply, and now let's zoom on the higher part of the hole, right there. You should see something like this. And now we have to use the inter-element averaging for bond misses stress. We go back to our standard view, the isometric view. On results, we go to create, fringe, select the plot options icon right there, select none on domain here, then we select derive average and shape fin. Finally, we click on target entities on current viewport, click apply, and now let's use the average extrapolation within each element. Create fringe again, select plot options, all entities, derive average, average, and finally apply. And that's the end of the tutorial. Thank you.